Hello everyone, welcome back to the Waking Rapid Manufacturers channel. This is TJ here. This is a thermal imaging device that helps us see things in environments where our eyes can't. Pretty cool, right? The product consists mainly of a sensor system, a data analysis system, a durable metal frame, and a protective outer shell. The durable metal frame is used to securely mount and shell the components of the sensor system and the data analysis system. It must withstand multiple environment challenges, including extreme heat, cold, and even underwater conditions. Aluminum alloy 6061T6 is one of the best choices. The material not only effectively meets the requirements of the above application scenarios, but also offers cost advantage over magnesium and titanium alloys. Before machining, carefully analysis of the product design joints and part assembly structure is necessary. The frame structure, as shown in the figure, consists of 6 integral parts: front PCB support plate, back PCB support plate, upper PCB holder, bottom PCB holder, TI detector holder, and EO holder. Now, let's focus on the PCB support plate and the PCB holder. As shown in the figure, the red area serves as a mounting area, and the surfaces of these parts must be accurately aligned before they are fastened with screws. As a result, we have set a positional tolerance requirement of 0.01 for parallelism at the corresponding position shown in the drawing for these 4 components. These strict requirements ensure tight and accurate fit, which guarantees optimal performance and reliability of the thermal image devices. Deformation is a common challenge when machining thin, flat parts. Reducing the feed rate during each machining operation and increase the numbers of machining passes. This allows the stress of the material to be released gradually and evenly. In the context of these 4 parts, this method allows precision requirements to be met while effectively managing machining costs for the customer. The TI detector holder and the EO holder plays a critical role in supporting sensor components designed to detect and collect signals from the external environment. The precision of these sensor components is critical, as any installation angle or position offset can directly affect the accuracy of the input data. The EO holder acts as a housing for the low-lux CMOS, a critical component in imaging system. The drawing shows that the positional accuracy of the purple EO sensor mounting position is defined with respect to the yellow surface A and the red surface B, with a precision requirement of 0.01 mm. In addition, the diameter accuracy of the purple area is specified as plus 0.02 to plus 0.05, which enables smooth mounting and effectively limits the sensor vibration in the mounted position. A 3-step approach is proposed to optimize the manufacturing process. First, the rough appearance of the part is quickly machined, saving time for precision machining in later steps. The second clamping process is a combined tolling and milling approach that machines the yellow, red, and purple surfaces in one pass to meet the position and accuracy requirements outlined in the drawing. The final step is to machine the remaining structure features. Special features are designed to prevent deformation of the parts during this process, ensure the overall identity and precision of the EO holder. The TI detector holder serves as a housing for thermal imager. Examination of the drawing reveals the presence of 4 holes designed to secure key components. Of particular importance in this case is the precise distance between the center of these circles, which requires a tolerance of plus minus 0.01 mm. To meet such high precision requirement, it is essential to use suitable clamping devices to ensure that the workpiece is held up flat and upright during machining. In addition, attention must be paid to the 2 red holes and 2 purple holes, which are concentrated circles. To ensure concentricity, it is important to machine these concentric circles in one single pass. Surface finishing is a critical step that should not be overlooked once the part has been machined. The oxide laser produced by military-grade 3 hard anodizing is significantly thicker, up to 50 mm. This results in excellent scratch and chemical resistant, make it an ideal choice for parts exposed to harsh conditions. That's it for today. Thank you again for joining us for this video, and we hope this case study sharing helps to build your trust in us. If you enjoyed this video, please subscribe to our channel and give us a like. See you next time. Bye-bye.